All right, so we're going to finish up chapter 3's review with some word problems. And then I'm going to start the review for chapter 5. And if I don't remember, someone tell me when I tell you we're starting chapter 5, tell me to stop the video and restart it. That way it shows up as 2 videos in the links. That way it's like you can separate the idea for when you need it. I don't know who that was, but you look hella fucking guilty, Malaya.
I got scared.
Oh, okay. That was Maddie though, right? Yeah. All right, so we were doing some word problems, or looking at usage of wording. So let's just start off with, what is 15% of 80? Percentage problems. When we were talking about yesterday, is usually an equal sign. So that's my equal sign here. What is some unknown? It's a question mark. We can use question mark if we want. Question mark's a valid variable. These two things, 15% of 80, I think we need to add this word to the multiply thing. When it comes to percentages, of means multiply. When you're doing, like when you do a percent of. So we want to multiply these two numbers, but this has to be as a decimal. We got to put that as a decimal. We're going to multiply it by 80. This should give us 12. There's another way to do these problems that are not like just looking at words. The way I learned this when I was growing up was the is of percent triangle. Was there, you did the initial quiz, was there a percentage problem on there?
On what?
The chapter 3 initial quiz?
Yeah, there was.
Okay. And we will always have 2 of these. And solve for the third. So I'll show you the 3 variations. I'll draw the triangle 3 times. We could have X up here and Y down here. I'm going to use X and Y like this just to show some stuff. Or X and Y down here. That's 3 possible combinations. And then the third one is always going to be our I don't know what's going on thing. If you use this triangle, this line right here acts like a fraction bar. That one right there. So for this right here, it's a fraction bar right there. This means question is equal to X over Y. And in this case, the question was the percent one. So the percent is X over Y. In this one, the question was the of question. This is also X over Y. You can jump straight to it. If the question mark is on top, these are side by side. This acts like multiply. And you'll notice that's what we did here. So rather than disassembling the word sentence and trying to interpret what it means, you can do this is of percent triangle and go a little bit faster. Being able to dismantle it as words is probably more beneficial to your overall word problem solving ability. So like here, to do this a little bit better, when we have a percentage of a number, like we did here, we want to multiply the percentage as a decimal, or multiply the number by the percentage as a decimal. Let's take a look at another problem. Let's do 32 is what percent of 45? Let's make it 48. Let's do 48. So again, the is acts like an equal sign. And my 32 is on the left side of that equal sign, so we'll put that there. And percent of, that should be a question mark right there. I wrote a percent symbol. This should be question mark percent of 48. So these, like in the last one, should be multiplied together. I don't know what it is, but I'm going to multiply it by 48. And if you want, we can use X. If you don't like using question marks. So we learned how to do this. We know how to do this. We get X by itself by dividing by the number multiplied by it. And I am getting 32 over 48, which I write it as a decimal. Zero 0.666666. But they asked what percent. So we want to write this as a percent. So when we do percents, we shift the decimal twice. And we're going to get 66.67% if we round it to 2 decimal places. You guys ready for some more? We haven't done yet. Good start. Oh, I didn't point out how that works on the thing over here. The unknown thing was the percent. That was this one right here. And so we could have jumped straight to X over Y. X is the is. And the 32 is next to the is. So this would have been 32 goes in the is spot. And the 48 is next to the of, so we're gonna put the 48 in the of spot. And we got question mark there. So question mark equals 32 over 48. And that's what we did when we solved it, converting it to words. So if you like the triangle, use the triangle. All right, now let's continue. Let me give you guys one to do. $14 is 20% of what number? We'll say value. What value? All right, let's go ahead and take a look at it. I look for my equal sign. My equal sign is here. And I got 14 on the left. And 20% is going to be 0.2. Of what value? I don't know what value. Let's call it X. In the triangle, this would have been 14 on top, question mark here, and 0.20 here. I'll put the 0 because that way it looks like 20%. Now you have a couple of options. You can jump straight to dividing. X equals 14 over 0.20. And that'll match what's over here. This is I told you like yesterday, get rid of decimals. Here, the decimals, there's only one single step, so going right to it, because you're going to do it in a calculator, is fine. If you are in the habit and you like getting rid of decimals, let's get rid of decimals. I see 2 decimal places, which means I need to multiply by 10 to the second power or times 100. And it means moving the decimal place right twice for each number. So this would become 1400 equals 20x. Then we don't have our decimals, and we know to divide the number in front on both sides. And I get x equals 100 or 1,400 over 20. Both of these you're going to see get you 70. When you have numbers like this, there's actually something pretty handy. When you have a 0 at the end of a number on top and bottom, you can actually cross zeros off like that. Because 1400 over 20 is the same as 140 times 10 over 2 times 10. And what we're effectively doing when we cross those zeros off is we're crossing off that 10 over 10. So if you're doing it by hand, that might actually make it a little bit easier for you. Any questions? Okay. Let's start doing some real world problems, not these percentage problems. Does anyone need this up longer? Okay. Maria works 40 hours this week. And 16 hours of overtime. Which overtime is paid at, they could say time and a half. Time and a half means 50% more. She made $1,600 this week. What is her hourly rate? Okay, so if we don't know how to jump to doing this in equation, let's try to reason out what happens. Okay, so if Maria works 1 hour, let's pretend let's say she makes $10 an hour. We don't know how much she makes, but this slide can give us an idea of what the math should look like. We know she makes X dollars an hour. We don't know what she makes, so we're going to call it X. But whatever we can set up with $10 an hour should work with X dollars an hour. So if she works 1 hour, she's going to make $10, right? She gets $10 an hour, and she works 1 hour, she gets $10. If she works 2 hours, she's going to get 2 times that $10. So she's going to get 20 bucks. She works 3 hours. She'll get 3 times $10, which is $30. Well, if I write this top one as 1 times $10 equals $10, I can start to see a pattern. I'm taking how much she earned that's this thing right here. That equals hours worked times the rate. Right? So 3 times the pay rate is 30. So if I convert the 40 hours a week, 40 hours a week at some unknown rate X, that's her earnings for that part. Earnings for the 40 hours. That's the regular pay. Now the overtime, she had 16 hours. And she's gonna get 50% more an hour. Well, how do we incorporate the 50%? Normally you make like 100% an hour, right? 100% of your rate you make an hour. She's making 50% more. 50% more would be 150%. Does that make sense as overtime? Well, 150% as a decimal is 1.5. So her hourly rate should be 1.5 times X for overtime. That's what I'll put in right here. And that's her OT earnings. Does that make sense? Like if she made $10 an hour, 50% more would be $15 an hour, and it would still go in there. But since I don't know what she makes, I can't just increase it by 50%. I have to do the equivalent of something like this. If I knew what she'd made, I just do the increase and I wouldn't write 1.5 times. But when I don't know, I'm stuck doing that. I know her total earnings was $1,600. If I did the total here, that's adding up these two, right? So I should be able to add these. So 1,600 should be the same value, because that's on one side of this equal sign, times equals the 40x. I don't know what the x is, so we'll say 40x, plus 16 times 1.5x. That's what happens if I add those two up. So this approach helps a lot. If you reason through it and like set up like a fake value for what you're looking for, like the $10 an hour, and you kind of do a couple steps to see what it looks like, you can try to make like an equation out of it. That's what I did here. I said 1 hour was this, 2 hours was this, 3 hours was this. I'm noticing a pattern, but the thing I don't know is the $10. So I'm going to replace the pattern with an unknown value X. And now we'll go the pattern all the way up to what she's got, 40 hours of regular pay and 16 hours of overtime pay. Now we can solve it. First off, I would do this multiply, get rid of that parentheses, distribute. We're going to have 1,600 equals 40x plus 24x. And I can add those two x's together. I get 40 plus 24 is 64. So I have 64x. You guys have a question? Yeah. If you got a question, will I ask? Anyone, ask. If you got a question, ask.
How did you, or why did you turn the 600? Oh, never mind. I did it wrong. Never mind.
Well, go ahead and ask. So if
No, I thought you changed the 1,600 to 16,000. So I thought you did something like that.
Oh, no, I just added a comma.
Yeah, I just looked at it.
And here I did 16 times 1.5. So now we deal with this, we divide both things by that value in front of the x. So x should equal 1600 over 64. 64 hours, basically, or the equivalent hours. 1600 divided by 64 is 25. Maria makes $25 an hour. How's that? You guys ready for more? Going the wrong way. Does anyone have a question? I know this isn't an easy subject. Let's do something you might like more. Let's talk pizza talk. Pizzas. Now, I looked this up over the weekend and I was checking several pizza spots because I was looking for one that had the right combination prices. So these are for custom large pizzas. At two different restaurants. At Round Table, which I'm going to abbreviate RT for the rest of this question. The base price is $20.49, and then you pay an extra $2.50 per topping. At Pizza Hut, we'll call it PH, this was $17.69 plus $2.90 a topping. So my question is, how many toppings are necessary, are required for both pizzas to cost the same price? The reason why I'm asking that is like Pizza Hut is cheaper per piece, like for very few toppings. It looks like with like one topping, it should be less. But like at some point, Pizza Hut is the more expensive pizza. So how many toppings does it take? So let's do the same strategy we did last time. Let's pick a pizza and like figure out how we can do this. Let's start with Round Table. If we do Round Table, it should translate over to the Pizza Hut with a similar pattern. If we had 0 toppings, just like a cheese pizza, assuming they don't count cheese as a topping, which is dirty if they do, that's fucked up. Cheese should be bare minimum, right? You have to pay the $20.49 no matter what. But we're not adding anything more because there's no toppings. So that's the price. If we had 1 topping, it should be $20.49, and we pay $2.50 more. at 2 toppings, I gotta pay $20.49. Let's say it's pepperoni and, 2 toppings at common one is Canadian bacon and pineapple. Let's say, I got it, dirty lovely. Who here hates Hawaiian pizza? You're alone in this room. You are wrong. You would say, you can't say someone's wrong about taste. Yeah, you can. I don't know if I told you guys this. Doesn't everyone like hot chocolate chip cookies? Like, isn't hot chocolate like when the gooey melty? Isn't that the best fucking way to have it? They smell delicious, they taste delicious, it melts in your mouth. I have a fucking friend that hates hot chocolate chip cookies. He likes his chocolate chip cookies frozen. He throws them in the freezer until they're fucking ice cold. That shit's wrong. It's borderline immoral, right? Canadian bacon and pineapple. So like you're paying $2.50 for the Canadian bacon and you're paying $2.50 for the pineapple. So if I wanted to summarize this is $20.49. I've got repeated addition and that's multiplication. 250 times 2. Well, if I look back, this is really like 250 times 1, right? On one topping, $20.49 plus 250 times 1. We didn't say times 1 at the time because that's just stupid. No one says that shit. But if I'm looking for a pattern, and that's what I'm doing, I want to make this an equation. I'm looking for a pattern. I could say the same thing right here. This is 0 times 250. So it looks like I'm taking the number of toppings and multiplying it by 250. Let's see if that works if I jump up to 3 toppings. 3 toppings, if I get a 3-topping pizza, I like pepperoni, olives, and like onions or bell peppers. Let's go onions. So I would have $20.49 and then $2.50 for my pepperoni, $2.50 for my olives, and $2.50 for my onions. It looks like that's again doing the $2.50 times the number of toppings. Does that make sense so far? Now, I don't know how many toppings I wanted. Let's go with Y. Y toppings. This pattern should hold. It should be $20.49 plus $2.50 times Y toppings. I don't want to use Y. Let's use T for topping. That's easier to remember, right? T for topping. Don't we know what our variable is representing? T for topping makes sense. And this was round table. Pizza Hut should have a similar process. T toppings on theirs is $17.69, but their toppings are $2.90 each. So we should have $2.90 T. Everyone good so far? Okay, so if I work this out, what is each one of these things I'm listing right here? That's the price of the pizza, right? This is the price. So the price of the round table pizza and the price of the Pizza Hut pizza. If I ask when the pizzas have the same price, What does same price mean in math? It means they're equal, right? The same means the equal right there. So that part says the round table price equals the Pizza Hut price. That make sense to everybody? Well, I've got a formula for the round table price and I've got a formula for the Pizza Hut price. The round table price is $20.49 plus $2.50 a topping. And the Pizza Hut price is $17.69 plus $2.90 a topping. And I didn't put the dollar signs here just because it takes up more writing. We will know that there's dollar signs there. But when we're done, T is the number of toppings, so that's what we're looking for. There shouldn't be dollars at the end. Well, now we've got an equation to solve. We finally got it into some math. What do we do with this? What did we do with it yesterday? Well, first thing is I don't like those decimals. I think it kind of clutters stuff up. So they all have 2 decimals. I can multiply this by 10 squared or 100. And what that does is it shifts the decimal point to the right twice. That makes this 2049 plus 250t equals 1769 plus 290t. Then we wanted to, t is our variable, but we got t on both sides. So we want to put the t's together. I find it easier to move the smaller t. Are you with me, Selena? You look like you're zoning out on me. To get the t's together, I'm going to move the smaller t. I'm going to subtract the 250t. And I bring my equal sign down. I got 2049 equals 1769. 2 minus 250 is 40. And this is why I write my t's with a curl. That way it doesn't look like the plus sign. Now we look like we did before, but we have a t instead of an x. So we subtract this, we want to get the t by itself. We subtract the 1769 on both sides, and we get 280 on the left and 40t on the right. I'm going to rewrite this up here where I have a little bit more room. Finally, I divide by 40. And I get t equals 7. At 7 toppings, they are the same price. Any questions? Notice at no point did I try to jump straight to the equation. With practice, a lot of practice, you quickly start going, I know how to get there quicker, and you don't need to do this. But while you're like not a math major, really, like the best approach to go is to make a little list, figure out what your pattern's doing, and make an equation off the pattern. Okay? Thankfully, this is only in the support course. You're not gonna have to do this shit in the stats part. There is word problem stuff in stats, but the idea here is to get you used to looking at questions of math in word form and translating it. You guys ready for a little bit more? We're almost done with section 3. One more topic I want to go over with you guys. And this is solving for a variable when there's other variables. For example, the volume of a cone your good old, snow cone. Is V equals 1/3 pi r squared h, where h is this vertical distance from the top to the bottom of the cone. And r is the radius of the circle at the end of the cone. Okay. So what I want you to do, or what we're going to do, is solve this for height, or the height h. Now, just as an example, if this said like 50 equals 10h, how would I solve this for h?
We divided by 10.
Dividing by the 10, right? Well, I don't have 50 and 10, I have v on the left. And then I have 1/3 pi r squared h here. We could do the same thing. I don't like this fraction. I'm going to deal with the one, yeah.
Oh, I was gonna say, can't you multiply 50 by 3 to get rid of the fraction?
Yeah, well, let's get rid of the fraction. That's right where I was going. Let's get rid of the fraction. And remember when we were doing this before, we multiplied by the LCD? But there's only one fraction. So the LCD is the only bottom that we have, which is 3. So I'm going to multiply both sides of this times 3. And if I do, I get 3v on the left, and on the right, the 1/3 and the 3 cancel out, and I have pi r squared h. And now there is a radius where this value is 10. I don't know what it is, but the principle is it's the same idea as what we did here. We divided by 10 here, we're gonna divide by what h is multiplied here. On this one, h is multiplied by pi r squared. So we're gonna divide both sides by pi r squared. And we will get h equals 3b over pi r squared. You guys ready to try one? Let's look at the perimeter of a rectangle. Perimeter means distance around the edge. And we tend to use P for perimeter. So like, let's draw a rectangle. We often call the longest side L for length. And two sides of that rectangle have that same value, they're the same distance. And we often call the shorter side W for width. And there's two sides that have that. Now, if I want to find the perimeter, the distance around the edge, it helps to pick a starting point and just go around the edge and start adding them up. So here, if I go around clockwise, starting at the upper left, the perimeter equals this L right here, plus we go around, we get to this side, we're getting that W, we're going to add that W in. And we're going to keep going around, we're going to add this L in, we'll add that L in. And we keep going around, and we got another W to add before we get back to where we started. If I add the L's together, I have two different L's, and I have, well, they're not different L's, they're the same L, and I have W, and there's two of the W's. So that's the equation for the perimeter of a rectangle. Your job, your mission, should you choose to accept it, is solve this for L. Give that a gander. Then we'll do it together, then we'll take a break. Anyone want to help me with this? Anyone feeling brave? Be brave. Okay, what if this was 50 equals 2x plus 20? What would I do here? I would subtract 20, right? Well, let's translate that over here. Let's do that here. The thing that's being added is this thing, so let's subtract that. And I will get P minus 2W equals 2L. And then over here, I would have had 30 equals 2x, and what would I have done here? Divide by 2, right? So I can do that here. I want to get L by itself, I'll divide by 2. So L is going to equal P minus 2W over 2. So if it helps, when you're like, I'm pretty sure one of these questions showed up on the initial quiz where they gave you a bunch of variables. Cody, you took it. Did they have one like this? So if you're not sure what to do, like put in fake numbers for every letter but what you're solving. I should put this back to an L. Put in fake numbers for everything else and go, what would I do if they were numbers? And then do the same thing with the letters. Any questions? All right, that's the review for chapter 3. Let's take a 5-minute break if you guys need it. Let me hit stop here. I will remember to stop recording all on my own.